Hi guys, tonight we're going to take a look at division properties of exponents. And so just like multiplication had properties, division also has properties. So if you remember with multiplication we had to add the exponents, and so we're going to do something similar with division, but instead of adding them we're going to subtract the exponents, and we're going to take a look at why that works, and it'll also explain why anything to the 0 power is equal to 1. So let's go ahead and get started. So make sure you have your notes that say Unit 3-5 Division Properties of Exponents video notes. So in example number 1, we're going to write this one out the long way. So we have 2 to the 8th divided by 2 to the 4th. So 2 to the 8th can be written as 2 times 2 times 2 times 2. We need 8 of them. I think I have 8 there, yep. And 2 to the 4th can be written as 2 times 2 times 2 times 2. So if we divide, we're going to look for ones that cancel. So I want to match a 2 on the top with a 2 on the bottom. These two cancel. 2 divided by 2 is 1. These two cancel. Again, 2 divided by 2 is 1. These two cancel out, and these two cancel out. So really what we're doing is just 2 divided by 2, 2 divided by 2, 2 divided by 2. So what we're left with on the top of our fraction is 4 2's. So we're left with 2 to the 4th. On the bottom, since 2 divided by 2 is 1, 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 we end up with a 1. And we can just write that as 2 to the 4th power. And if we wanted to write that expression out, we could. So we're looking for a shortcut again. How do we go from here, from 2 to the 8th divided by 2 to the 4th to 2 to the 4th, and skip this step inside here? So what we can do, with multiplication we have the add the exponents. With division we're going to do the opposite. It's just going to be 2 to the 8 minus 4. Because 4 of these canceled out 4 of these. So 4 of these 2's cancel out 4 of these 2's, and what we're left with on the top is just 2 to the 4th. And if we wanted to write that, we're going to leave it. We're not going to put it in standard form. We're not going to find the value of the expression. We're just going to leave it as 2 to the 4th. So this is the property. And sometimes properties can be confusing, but basically what this is saying, if we divide two numbers with the same base, we subtract the exponents. The only thing is a cannot be 0, because we can't divide by 0. So let's try x to the 7th divided by x to the 3rd. And then pause the video and see how you do. So I'm going to do it the long way. I need 7 x's on the top, because I have x to the 7th, 3 x's on the bottom. These are going to cancel, these are going to cancel, and these are going to cancel. And I'm left with, I'll write it over here, 4 x's on the top. The shortcut is x to the 7 minus 3, and I also put x to the 4th, so my answers match. So in example 2, what happens when we have a fraction like 3 over 2, which is division, and that's raised to the 3rd power? So what this means is I need 3 over 2 3 times. So 3 over 2 times 3 over 2 times 3 over 2. If I multiply 3 times 3 times 3, that's what goes on top. And on the bottom is 2 times 2 times 2. 3 times 3 times 3 is 27, and 2 times 2 times 2 is 8, and I end up with 27 over 8. I can also rewrite that if I wanted to. I could simplify it into a mixed number, but we're going to leave it alone. So the shortcut for this is similar to the multiplication property we did last night. This has an exponent of 1, this has an exponent of 1. I multiply 3 times that exponent and 3 times that exponent, and I end up with 3 cubed over 2 cubed, which is equal to 27 over 8, the same answer we got before. So this is what we call the quotient to a power. So again, if we have division raised to a power, we do the same thing. Make sure this has an exponent. So if there's not an exponent, you give it a 1, and m gets multiplied by that exponent, and m also gets multiplied by that exponent. So I think it'll be a little clearer in this picture, or in this example. So if we have 4 over x squared, we're going to write that as 4 to the first. We're going to multiply 3 times that exponent and 3 times that exponent. So we'll get 4 to the 1 times 3 and x to the 2 times 3. This will give us 4 to the third. X to the 2 times 3 is x to the sixth. And we can evaluate this. 4 to the third is 64. It's a perfect cube over x to the sixth. Okay, so you should have gotten 2 notes sheets for homework. So let's take a look at this. Okay, it says Unit 3-5, Classwork Division Property of Exponents. So these are your video notes practice. So for number 1, you're going to expand 1, 2, 3, and 4. You're going to expand to find the quotient. And that's what we did on the other set of notes. So let's go ahead and do that. So 2 to the 4th is 2 times 2 times 2 times 2. And 2 to the third, whoops, too many 2's. These are going to cancel, and I'm left with 2 over 1, or I could write that as 2 to the first, or I could just write that as 2. The shortcut again would be 2 to the 4 minus 3, and that's going to give us 2 to the first. So do the same thing for 2, 3, and 4. And in number 5, explain why you can subtract exponents when you're dividing 2 things with the same base. So what it's asking you in this question down here is asking you, why does this work? So you need to answer questions 2, 3, 4, and 5. So I would like to do a couple of these together, namely number 10. So number 10, luckily we have all positive exponents. There's just a 12 here, so I'm going to rewrite my 12. There's no number underneath to divide it by, so these two, g to the 8th divided by g to the third, is going to be g to the 8 minus 3. And then h to the 4th divided by h to the 5th is going to be h to the 4 minus 5. The 12 is going to stay the same. 8 minus 3 is 5, so we get 12g to the 5th. And then 4 minus 5 is negative 1. So you can leave your answer like this, but we prefer positive exponents. So we can write this as 12g to the 5th and then 1 over h to the 1st. Let's take a look at example 13. Okay, so 13, we have 2/4. 2/4 can be simplified to 1/2. So we're just simplifying the fraction. We have an x on top, so we're just going to leave the x alone because nothing happens to it because I don't have any x's on the bottom. And then we have y to the 8th divided by y squared, so that's y to the 8 minus 2. So the 1/2 is going to stay the same. The x to the third we didn't have to do anything to. And then y to the 8 minus 2 is y to the 6th. And we are finished. And that's it. Okay, so try the rest of the examples by yourself, and then we will check them out in class tomorrow. And once again, if you have any questions, please record them on your video notes so you can ask them in class tomorrow. Have a good night.